In this video, we're going to look at magic methods, and we're going to help uncover what a lot of these double underscore attributes that you see really mean. We saw before, if you have, let's say, a string, and you look for the dir of the string, you see a lot more attributes than just the ones that you might be familiar with or ones that you understand are methods of the string class. Methods like replace, rstrip, split, split lines, these are all familiar to us. Other ones like, let's say, capitalize or center, we can learn about, of course, using help or by looking at other documentation. But what are these magic attributes? This is what we call them, magic attributes. Anytime you see a double underscore before and after a name, it's known as a magic, hidden, implicit sort of attribute. We can think of them almost as behind the scenes attributes. They're ones that get activated implicitly. What does it mean to say that a magic attribute is activated implicitly? Let's keep going with some of our definitions here. A magic attribute is denoted by double underscores on either side of a name. Magic, implicit, hidden attributes are ones that are activated indirectly. So what do I mean by that? Well, consider init. Init is a magic variable, and as we've seen, it's an attribute of the class, so we can call it a magic attribute. And it doesn't get called directly, does it? When does init get called? We know that init gets called when we create a class. And sometimes we say automagically. Magic, the word magic is actually something that you will find in common parlance and discussion of these types of attributes. A magic attribute is called automagically. Magic actually refers to it happening behind the scenes. So when we say that a magic attribute is a hidden attribute and is called implicitly, meaning activated indirectly, oh, that didn't work out. That's the reason we use the word magic, because it's happening without us seeing it. It's happening behind the scenes. And here's the example. When we create a new instance, this magic attribute is automatically activated and init gets called. Init is the class attribute of the value class. It is a method, and it gets called automagically. Of course, this implies that the init attribute with double underscores on either side is actually a reserved name. It's a name that Python knows about because it must know about it because it's calling it automagically. It's not because it's sitting here as the first method or something like that. For instance, let's say this. I'll just put in a statement here that says I'm calling it print, and I'll say instantiating. That means constructing or creating a new instance. If I run this, I'm certainly going to see that. But let's change the name of init. Let's just leave off one of the underscores or maybe leave off an I. And now it's not anything we could expect at all. And it doesn't say instantiating. In fact, it gives us an error because it's not calling init anymore. At least it's not calling our init. As we saw before, it's actually calling the object init. So, okay, we could maybe misspell init and call it without arguments. It's going to work and it'll be fine. But init's not getting called, and that's because this is a reserved name. All of the magic attributes that you see are reserved names. That is, they're ones They're ones that that Python knows about, and that Python will call when certain events happen. The event in this case is the instantiation of an object, constructing a new object. It automatically calls value.init. But what about all these others? What are they all for? We've got ones like add, contains, delatter, EQ, GE. We've got other ones that we might sort of recognize. There's an attribute called dir. I'm not sure what that is. We've got the doc attribute. I actually showed you that one. That one gets it gets assigned the doc string for the class. We'll look at that a little more in a moment. But let's look at one that can help elucidate this. It's a method called stir. I'm going to go ahead and stir. Now stir is obviously another magic attribute. You know it's magic because it has double underscores on either side. And when PyCharm catches up, this will be colored purple, I think. What happens when we change it? Does it change color? We'll find out in a second. This magic attribute is reserved, as I mentioned. It's built in, or it's understood by Python. And what it does is it gets activated when we do a particular thing. See, the color finally changed. It's no longer deep purple here, or whatever color that is. Lavender. No, not lavender. It's now acting like a normal method. If I change it back to the reserved word, PyCharm's going to notice and color code it correctly. Well, when does stir get activated? Well, if I say print mynum, Python's going to need to convert that object to a string. And and when it does that, it activates the stir attribute, class attribute. Let's take a look. Okay, gives us value object 10. So here's how a stir attribute works. If you're building your own classes and you would like your class, your instance, to print something in particular when you print the object. See, we're not doing anything to the object except printing it. We're not doing anything to this instance or to this object except for printing it. Printing it means we have to convert it to string. And when we do, stir gets activated. And whatever stir returns, that's what's going to get printed. So now when we print mynum, it says value object 10. We define what should happen when we print the object. Now, I don't know if you can see a use for that, but I want you to imagine that you're working with some sort of object that was designed by, your colleague or yourself or whatever, and you would like the object to be able to tell about itself or show you something specific when we print it. And when we print a list, for example, it'll show us all the items in the list. Or if we print a string, we'll see the characters in the string. That's sort of been intuitive and not that surprising, since that's how it works. That's how we that's how these objects have worked in the past. But when we lift the hood and we take a look at the inner workings of Python, we see that these magic methods help control what the object does. Let's look at another example. I'd like to add this object to another object. Now, right now, I've started off the value object with a value of 10. And of course, internally, that class is simply storing that value in an attribute. But let's say I'd like to be able to add an integer to the value object and have it change its attribute so that it's no longer 10. How could I affect that? I guess what I'd like to be able to do is say, let's make it simple. X equals mynum plus 100. And I would like to see that gets me an integer and 110. In other words, I would like my value object to act like an integer if I ask it to. That's what I'd like to see. I'd like it to act like an integer if I ask it to. As long as I add an integer to the object, it should act like that. Well, all right. First off, understand that the magic attributes have been activated when we do certain things, right? Here, when we printed mynum, it automatically calls mynum.stir. And that's true. It does. As it turns out, everything that we can do to an instance or an object, everything that you can do, and think about the different things that you've done with the object, aside from calling methods on it, which of course we can define as many methods as we want, what are the other things that have been done to objects? Think about it for a second. What can you do with integers, for example? You can do math with them. Is that right? And aside from methods, what can you do with strings? Think about it for a second. What can you do to a string besides calling methods, which is one way to activate functionality? But what are some of the other things that we've done with strings? We have concatenated strings with plus. We have repeated strings with star. We have sliced a string, and we've subscripted a string, and you can even loop over a string. That's a lot of functionality for a string. And it's a lot of functionality that isn't dependent on the method names. There are actually just some built-in ways that we operate on objects. What can we do to a list besides calling methods? Well, we can slice a list. We can subscript a list. We can even add two lists together. I don't know if you've ever done that, but you can add two lists together with plus. You can for loop over a list. You can get the length of a list. So many things that we've done with lists or strings that don't involve methods. Or do they? Here's the thing. When we do an operation on, let's say, this variable or on any integer or any string, we're not actually using an operator. We're actually calling a method. I'll tell you what I'm going to do is I'm going to tell you that if we use the plus operator, Python is going to automatically call, in this case, mynum.add 100. Now take a look at that. Here, over here on the left, I'm saying mynum plus 100. On the right, though, what I'm saying I'm actually doing is calling mynum.add. Now, how does that happen? I mean, why would it call it automatically? Well, look, didn't we just say that all these attributes, these double underscore attributes, like add, are getting called implicitly? That's how you call the add method. Why don't we implement the add method here? In fact, the add method. Now this is going to get a little weird, but I want you to look closely at what's happening here. I just suggested to you that when we say object plus 100, we're actually saying object.add 100. Plus is something that we call syntactic sugar. And this syntactic sugar is just something that's pretty and easy to use, very palatable, just like candy. But it's actually not, it's empty calories. Well, it's not empty calories. It's not an entity of its own. It's actually standing in place of something. And what operators stand in place of are methods. Operators actually activate methods. So instead of mynum plus 100, it's actually mynum.add 100. Now, if you look at the add method, you can see We've got a standard self, which is always going to be there, and this extra value, which in this case would be 100. We're then returning the current value of AAA, which I think is 10, plus the 100. That's why we're hoping to get 110. I really want to add the 10 that was part of this value and is stored in this mynum variable. I want it to act like math when we say value object plus 100. In other words, I'd like it to say 10 plus 100. I'd like it to be 110. Let's see if it is. And there it is. When we print mynum, Python automatically calls mynum.stir. And when we add to mynum with a plus, Python automatically calls mynum.add. And this is all built into the language. Stir, add, and many other attributes are activated automatically when we do certain kinds of operations. Now, I don't know if you're thinking this through yet, but I want to imply to you that if the way Python works is that when we use the plus operator, it actually calls .add on the left operand, which is mynum, then it must be that strings and integers and even lists have the add method. Do you see why? Because we can say hello plus world, and we can say 5 plus 10, and we can even say list plus other list. We've never really looked at this, but this creates 2 new lists with the whole thing in it. Wouldn't it mean that each one of these object types must have an add attribute? I should think so. Let's take a look. Add. Let's do the dir of int. Add. Let's do the dir of list. Add. They all have add. Any class that has the add attribute, the add a class attribute, and having it be a method, has implemented plus functionality. Plus is just a really, really easy, intuitive way to allow us to work with objects, because everybody knows what 2 plus 2 means. And by now you also know what it means to add one string to another with plus. It'll concatenate them. The functionality that takes place with plus is defined in a method called add, _add, for every object that wants to use the plus operator. Now let's take a quick look at some of these other things that we might do with a string or a list. Here it is for the string again. Let's do a dir of stir. I'm now going to tell you what some of these attributes actually correspond to in syntax with which you're already familiar. You're already familiar with the plus operator. Well, now you know that the plus operator actually activates add. You're familiar with the in operator, are you not? If this string in that string. Remember that from session 2? If this string in that string. The name of that magic method is contains. What about slicing a string? Oh, I always get this one wrong. What about subscripting a list? Let's do a dir of list. Subscripting is known as getItem. That's the magic method that's called when you try to subscript a list. And actually, we can subscript a dictionary too, can't we? Yes. And getItem is defined for a dictionary as well. Now, of course, we've seen that, using the same operator on different objects might give you different results. For example, a list getItem requires that you use an integer index, right? List subscript 0. A dictionary subscript requires that you use an integer, float, or string, and not something like a list or a set. They all work a little bit differently, although they are often very similar. But the reason this works, the reason you can subscript a list, you can subscript a dict, or you can subscript even a string, or even a tuple, is that those classes have defined getItem. So does this mean that we can define getItem and have it allow it to subscript our object? Why not? I'll just print getting item at IDX, and we'll simulate what might have happened if you try to subscript. Let's find the minum. Sorry, we'll say minum subscript 0, and then we'll say minum subscript hey, what up? Now, as I've mentioned, it's this automagic functionality is automagic. Automagically call minum dot getItem, and this is going to be 0. Now look to the left and look to the right of these various things that we do, and understand that this is just implicit with Python. This is implicit. This is how things work with Python. If you want your class to be subscriptable, you have to define getItem. Let's try it and see if it's working. Okay, bad syntax. We, I think, attempted to comment and didn't succeed. Let's try again. Getting item at 0, getting item at hey, what up? Take a look at the two calls or the two subscriptings that we did, and take a look at getItem up here. And understand that just as it says on the right, when we subscripted the object with a 0, it automatically calls object.getItem 0. And when we subscripted the object with hey, what up, it automatically called object.getItem hey, what up. It doesn't really matter to Python, because the truth is when you're subscripting an object, you're not really doing anything except calling that method. There are also attributes for looping, which we call, there's two of them actually that we need to use together. One's called next, and that's for getting the next item. And the other one's called iter, and that's for setting it up to be iterable. Now, think about some of the operators that you use and see if you can tell me what some of these things are. What about EQ? What do you imagine that would correspond to in terms of things you've worked with in the past? Operators, perhaps, that you've worked with. EQ is the magic method for the equivalence operator. GT is the magic method for the greater than operator. LT for less than. GE for greater than or equal to. LE, I imagine, for less than or equal to. So you see many of the things that you've wanted to do with objects, or that you have done with objects, especially with things like operators, or let's say for looping, or subscripting, or slicing, were implemented in the class using these magic attributes. Now that kind of brings us back to something we asked when we were looking at inheritance. Why do we have, if I print the dir of, any class at all, it doesn't even need to be special. But if I print the dir of a class like value, I'm going to see a very large list, or a rather large list of attributes. And I'm, of course, going to want to ask what they are and why they're there if we didn't define them ourselves. Or if we go back to one of the earlier examples like do. If we have something like do and we do the dir of do, back to the dir of do, let's look at the dir of do. Whoops, I ran the debugger. Let's run it again. When we do the dir of do, even though do has only what? Cval and do this, we see all these other things. Well, one of those is stir, and really any object needs to be printable. Python wants to ensure, the designers of Python wanted to ensure that if you were to, let's say, print the object and it were to get converted to a string to be printing, that you won't see an error. What do you see? What you see is a basic description of what this object is and what module it's located in, the main module, as provided by object. Object is that granddaddy class or grandmama class that provides functionality to every object that gets created. It doesn't matter where it gets created. It has access to this functionality where you can do things like print the object or do other things with it. Now, I'm not sure why class, let's see, we don't have GT, we don't have GE. I mean, what are these for? Kind of want to see what would happen if I were to say print do greater than 5. I mean, would it allow it or would it like fail in some weird way? Okay, it says it's not supported between a class and an int. Oh, yeah. Let's do an instance of the class. Did I do an instance? Let's try it. So let's do the greater than. Let's activate the greater than method of the object class and see. All right, just says I can't do that. Fine, not really a surprise, but I can probably say with some assurance that this exception was raised by the object class. And it's basically saying, yeah, I can't do that because you didn't implement the GT or LT methods. Now, the very last thing that I want to mention, and this kind of combines the magic attributes with inheritance, is this idea that we can inherit from built-ins. Here we have a class intList. And of course, if we want to do something like, print it or something, we're going to see something basic. We'll see that I got an intList object. Fine. I just created an intList object. There's intList. But what would it be if I were to inherit from list? Now, I'm not sure if we're going to see the same thing. Look at what we see when we print the X now. Look at that. It's an empty list. Now, why would it be? Let's go even further. Let's uncomment these lines and show you that you can append to this object. Now, this isn't a small thing because I didn't define any list behaviors for intList. This isn't a list. This is my own. I could call it whatever I want. How do you spell gabagool? I could call it gabagool. It's not because it's called intList. I can go ahead and treat this thing like a list all the way up and down the line. I can subscript it. I can loop through it. And it will act like a list. And why is that? Basically because when we inherit from list, we are accessing or we can access any of its attributes. And don't forget, the list class is filled with methods that you can use. Not only methods that it defines explicitly like append, but also methods that are activated implicitly, like when you loop through the list or when you subscript the list. Here I should see what? First I should see a 5. Let's see. There's your 5. I can subscript this gabagool object because it inherits from list. I can append to it because it inherits from list. I can cycle through and iterate over it because it inherits from list. And list implements many of those methods that are necessary. Didn't we say this calls list getItem, which is the method that we chose, that Python defined for any kind of subscripting. This is really weird. This calls list.iter and then list.next. And of course, append is calling list.iter, last.append. Now, what's really crazy about this is that what this implies is that you can create a class that acts like a list, but you can do more than that. You can extend what this class does. What if I wanted to create a list? I'll call it double list. And every time first off, it would let's say reject any value that's not a number. But we could do that somewhere else. And let's say that I define my own append method. Now this gets a little bit involved, but this is the last thing we'll look at as far as inheritance and these magic attributes go. If we inherit from list, we can define append ourselves, and then we can change the way this append will work with this object. When I pull this out and I look at these values again, they're going to be 10, 6, and 200, as long as I've got my cards in order. I've just created an object that acts like a list. It responds to for looping and subscripting and append, but I've extended the functionality of the append method so that it will append double the value. Why do I do that? Why not? Doesn't matter. What I'm trying to show you is that we can sort of get right in with the built-ins that we know, and also the built-in functionality that we know. And we can either replicate that functionality using the magic methods, or we can call the parent class to do the things that we want it to do. Inheritance makes all of this possible. It makes it possible for us to create objects that are integrated with the Python ecosystem. Objects that subscript, objects that loop, objects that can be sliced, objects that tell you their len. And we can build that in either as an object that just is its own object and does these things, where we can use operators and subscripting and stuff like that. Or we can inherit from an existing class and have it be, let's say, list-like and act like a list in many cases. Rely on the list functionality as part of our class's functionality. It's very exciting. And the possibilities are endless. For you being able to create a new object type that's very useful and very easy to use by your user. Because if you can implement subscripting or the plus operator or the minus operator, everybody knows what those things mean. Everybody knows what a subscript is. Everybody knows what a slice is. You may make it mean something slightly differently for your object, but you can give your object to people and say, here, just create a new object here, and then you can loop through it. And they'll know what to do. So it makes it really easy to create your own object type that has really an almost instantly recognizable interface. If you say that it's list-like, that's all people need to know. List-like means you can subscript it, you can loop through it, you can do these other things with it. And it's very exciting to think about how you can integrate your own classes into the Python ecosystem.